The day MiG-29s tried to surprise the Eagles, and this happened. March 13, 1999, skies over northern Kosovo, 2:37 p.m. The roar of the Klimov RD-33 engines tears through the silence of the Balkan afternoon. Two MiG-29 Fulcrum fighters of the Serbian Air Force cut through the clouds at Mach .9, their olive-green camouflage merging with the mountainous terrain below. In the front cockpit, Colonel Milenko Pavlovich grips the controls, his eyes fixed on the N019 Topaz radar. The phosphorescent green screen pulses with ghostly echoes. Nothing yet. His wingman, Captain Zoran Radosavljevic, maintains tight formation 300 meters away, also sweeping the electronic horizon. Pavlovich smiles behind his oxygen mask. He knows these mountains. He has flown over them during dozens of training missions. He knows every valley, every rocky ridge that can mask his approach. And he knows above all American arrogance. "They think their Eagles are invincible," he muttered to himself during the morning briefing, tracing routes on the plastic-covered map with a red marker. "We'll show them what a Slavic pilot can do." The confidence was not unfounded. The MiG-29 represented decades of Soviet air combat doctrine, a pure interceptor designed for a single mission: to destroy enemy aircraft. 9 tons of aluminum alloy and steel armed with R-73 and R-27 missiles, helmet-mounted sights, extreme maneuverability. In theory, it could face any Western fighter on equal terms. In theory. But as Pavlovich crosses the airspace toward the NATO patrol corridor, 80 kilometers to the north, another fighter has already detected him. F-15C Eagle, call sign Dirk 52, Captain Jeffrey Wang at the controls. The Eagle's APG-63 radar locked onto the contact 43 seconds ago. 2 bogies, supersonic speed, altitude 7,200 meters, vector 185 degrees, distance 72 kilometers and closing. Wang does not need to confirm the identification. The flight patterns, the radar signature, everything screams MiG-29. He has already faced fulcrums in red flag exercises. He knows their capabilities. He knows their limitations. And he knows something Pavlovich does not. The Eagle's Link 16 system is processing data from 4 E-3 Sentry AWACS orbiting at 100,000 feet, 2 Aegis destroyers in the Adriatic, and 8 other Eagles distributed in CAP patrol along the Serbian border. Wang is not just seeing 2 MiGs. He is seeing the entire battlefield, rendered in real time, every friendly and enemy aircraft plotted with surgical precision on his multifunction color display. Pavlovich flies alone. Wang flies with a network.
Dirk 52, Magic. Confirm bogies at Bullseye 095, 70 clicks, Angels 24. Cleared to engage, weapons free. The calm voice of the AWACS controller resonates in Hong's helmet. He presses the transmitter. Magic, Dirk 52. Copy weapons free, engaged. 68 kilometers now. Pavlovich still sees nothing on his radar. The MiG-29's N019 system, although advanced by Soviet standards, has an effective range limited to about 70 kilometers against medium cross-section targets. And in in ideal conditions, without electronic interference, without ground clutter. Hong activates the electronic countermeasure system. Radio frequency pulses saturate the spectrum, creating false echoes, digital ghosts dancing on the enemy screens. 64 kilometers. Pavlovich frowns. His radar has started showing erratic returns, multiple contacts appearing and disappearing, impossible to determine which is real. He adjusts the filters, tries to compensate. Nothing. The screen remains cluttered. "Zoran, are you seeing anything?" "Negative, leader. Too much noise. I might be picking up jamming." 60 kilometers. Hong waits no longer. His finger finds the firing button. Two AIM-120 AMRAAMs leave the Eagle's ventral rails in half-second sequence, white plumes of fire marking their trajectories as the solid-fuel motors accelerate them to Mach 4. The missiles are autonomous, active radar on board, independent processing, no continuous illumination required from the launcher. Fire and forget. Hong is already turning, gaining altitude, preparing for a second engagement if necessary. 58 kilometers. The MiG-29's RWR, radar warning receiver, explodes in electronic cacophony. Red lights flash. A high-pitched tone pierces Pavlovich's ears.
Missile launch! Missile launch! The onboard computer identified the threat. Active missile approaching at hypersonic speed. Time to impact, 32 seconds. Pavlovich pulls the stick violently, the MiG-29 entering a 9G vertical turn. Gravitational force crushes his body against the ejection seat. Peripheral vision darkens. He fires flares, incandescent magnesium cartridges ejected in rapid sequence, each burning at 3,000 degrees, trying to trick the infrared sensors. But AMRAAM is not heat-guided. It is radar-guided. 28 seconds. Zoran Radosavljević sees the white trail of the missile cutting the sky like an accusing finger. Instinct overrides training. He breaks formation, diving downwards, pushing the RD-33 engines beyond operational limits, seeking the protection of ground clutter, where echoes from the mountains might confuse the missile's radar. 18 seconds. Pavlovich is in an inverted spin now, the MiG revolving on its longitudinal axis, attempting to present the smallest possible radar cross-section, a desperate maneuver few pilots would dare execute so close to the ground. 12 seconds. The AMRAAM's active radar has locked. There is no escape. Algorithms correct trajectory. Control surfaces adjust the angle of attack. The missile is inexorable. 5 seconds. Pavlovich sees the white dot growing on his canopy. He knows. Every fighter pilot knows that moment, when physics wins, when there is no more time, when all hours of training converge into a single instant of terrible clarity. His hand moves to the ejection handle.
Detonation. The 40-kilogram fragmentation warhead explodes 3 meters from the cockpit. 900 tungsten fragments perforate the fuselage, wings, fuel tanks. The MiG-29 disintegrates into an orange fireball visible 50 kilometers away. Pavlovich did not have time to eject. His death is instantaneous. Vaporization before nerve endings can register pain. Zoran Radosavljević is 4 kilometers away when he sees his leader die. The second AMRAAM finds him 8 seconds later, while he is still in his escape dive. Impact on the right engine. Secondary explosion. The MiG enters an uncontrollable flat spin. This time, the ejection works. The K-46D seat catapults him out at a speed sufficient to break 3 vertebrae. He will survive, but he will never fly again. Total engagement duration, 93 seconds. Visual combat distance, 0. Pavlovich never saw the Eagle. Jeffrey Huang returns to base in Aviano 40 minutes later. 2 confirmed kills. First real combat mission. He is 26 years old. In the debriefing, an intelligence analyst shows the telemetry recordings. The numbers are cold, precise, unequivocal. The MiG-29s were defeated not by superior piloting, Pavlovich was a 17-year veteran, but by superior systems, longer-range radar, integrated data link, more advanced missiles. War is no longer fought within visual range. War is fought in the electromagnetic spectrum, where information is a weapon and the network is armor. A senior NATO official observing the data summarizes it in 3 words. That wasn't even fair. But war never is.
The false parity. How the MiG-29 was born to face the F-15. Moscow, 1969. OKB-155, Mikoyan Gordovich offices. Soviet engineers knew they were losing the race. KGB intelligence reports confirmed the American development of the F-15 Eagle, an air superiority fighter designed specifically to dominate the skies over Europe in any conflict with the Warsaw Pact. The leaked specifications were alarming. Look-down, shoot-down radar, capable of detecting targets against ground clutter, medium-range missiles, sustained supersonic speed without afterburner, a thrust-to-weight ratio superior to 1:1. Nothing in the Soviet inventory could compete. The MiG-23 Flogger, then the main frontline fighter, was a third-generation interceptor, fast in a straight line, but with maneuverability compromised by its variable sweep wing. The Su-15 was even more limited, essentially a crude missile designed to destroy strategic bombers, useless in a dogfight. Even the venerable MiG-21, produced by the thousands, was obsolete against the new Western threats. The Soviet response needed to be radical. In a classified Politburo meeting in March 1969, Dmitry Ustinov, then Minister of Defense Industry, presented the requirement: a new air superiority fighter capable of engaging the F-15 in combat within and beyond visual range, with sufficient maneuverability to win dogfights, radar capable of detecting multiple targets simultaneously, and, crucially, mass-producible, because numbers still mattered in Soviet doctrine. "We cannot allow a technological gap," Ustinov declared, pounding his fist on the table. "We cannot allow the Americans to dominate the European skies. Every NATO airfield must be under threat from our fighters. Every F-15 crossing the border must know it can die." OKB-155, Mikoyan Gordovich, received the contract. Rostislav Belyakov, chief engineer, assembled a team of 300 designers. They had 5 years to develop an operational prototype. The program was designated Izdelye 9.01, Product 9.01. But the challenges were monumental. The Soviet Union did not possess the American industrial base. Their turbines were less efficient. Their electronic systems were heavier and less reliable. Their metal alloys were weaker. But they possessed something the Americans underestimated: advanced aerodynamic theory, developed by TSAGI, the Central Aerohydrodynamic Institute, which allowed them to compensate for engine deficiencies with airfoil efficiency.
The solution was radical. LEX, leading-edge root extensions, aerodynamic surfaces added at the root of the main wings, generating controlled vortices at high angles of attack, stabilizing airflow over the wings, allowing for extreme maneuverability even at low subsonic speeds where Western fighters would stall. It was technology neither the F-15 nor the F-16 possessed to the same scale. Pyotr Ofimtsev, a theoretical physicist, contributed another innovation: computational analysis of radar signature. While Americans were still relying on empirical wind tunnel tests, the Soviets developed mathematical models to predict electromagnetic reflection. The result? The MiG-29 fuselage incorporated faceted angles, reducing the radar cross-section, not to the level of true stealth, but enough to decrease detection range by 20 to 30% compared to conventional designs. It was primitive compared to what would come with the F-117, but it was functional. 1974. First prototype. The Izdelye 9.01 rolled out of the hangar at Zhukovsky in October 1974. It was visually impressive: aggressive lines, air intakes with FOD guards, foreign object damage protections, allowing operation on damaged runways, a raised cockpit for excellent visibility, twin engines with partial vectoring nozzles.
But the first flight was a disaster. Test pilot Alexander Fedotov took off on October 6 at 9:23 a.m. 8 minutes into the flight, during the transition to supersonic speed, severe vibration began. The instrument panel oscillated. The controls stiffened. Aerodynamic flutter, resonance between the wing structure and airflow, threatening to break the airfoil. Fedotov cut the afterburner, decelerated, and made an emergency landing. Inspection revealed microfractures at 6 critical structural points. The design was fundamentally compromised. Belyakov had to start over, redesign the wing structure, reinforce the stringers, altered the aerodynamic profile. 12 months of work lost. In a tense meeting with VVS, Soviet Air Force, Colonel General Pavel Kutahokhov was blunt. If this fighter cannot fly, we have no defense against the F-15. Find a solution. I don't care how much it costs, I don't care how long it takes, but find one. 1977. Second prototype, Izdeliye 9.12. The 9.12 incorporated all the corrections: reinforced structure, new air intakes, analog fly-by-wire flight control system, steel cable replaced by electrical signals, allowing computerized adjustments in milliseconds.
First flight, April 25, 1977. This time, it worked. Fedotov pushed the fighter through the full test envelope. Maximum speed, Mach 2.25. Operational ceiling, 18,000 meters. Initial climb rate, 330 meters per second. Most importantly, maneuverability. The 9.12 sustained 9 Gs in a coordinated turn, executed the Pugachev's Cobra, a maneuver where the aircraft pitches up to 90 degrees, decelerates drastically, then resumes normal flight, useful for forcing a pursuer to overshoot in a dogfight. It was capable of surpassing the F-15 in visual combat. But it still had critical problems. The N019 Topaz radar. Developed by Physitron NIR, the radar was technically advanced, a pulse Doppler radar capable of look-down, shoot-down mode, tracking 10 targets simultaneously, engaging 2, but it was heavy, 380 kilograms, and unreliable. Failure rate in initial tests, 42%. Electronic systems based on thermionic tubes burned out frequently, requiring extensive maintenance after each mission. Western engineers were already using solid-state transistors. The Soviet Union was a generation behind. General Katakov, in a report to the Ministry of Defense in 1979, "The radar works when it works, but we cannot send pilots into combat with systems that fail half the time. That is unacceptable." Physitron was ordered, improve reliability to a minimum of 85%, or the contract would be canceled. It took 3 years. 1982. Initial production. The MiG-29 was finally accepted for operational service in August 1982. NATO designation, Fulcrum. Production began at 3 factories, Moscow, Nizhny Novgorod, and Irkutsk, with the goal of producing 1,200 units by 1990. But entry into service revealed more problems. Pilots complained about deficient cockpit ergonomics, obsolete analog instruments, lack of a hands-on throttle and stick HOTAS system. Pilots had to take their hand off the stick to operate the radar, weapons, countermeasures. In high-speed combat, seconds matter. Every extra movement is a vulnerability. Range was limited. Internal tanks held 3,500 liters, allowing only 1,400 kilometers of combat radius without external tanks. The F-15 had 60% more range. But the biggest problem was doctrinal. The Soviets designed the MiG-29 to operate within a highly controlled environment, ground-controlled interception, GCI. Ground controllers would use fixed high-power radars to detect targets, then vector MiGs for interception. The fighter would merely be the executor, not the decision-maker. This worked in theory. In practice, it required massive communications infrastructure, easily destroyed by a preemptive attack.
and it required pilots to trust controllers blindly, obedience that was not always guaranteed under combat stress. The F-15, by contrast, was designed for autonomy. The pilot made the decisions. Onboard radar detected threats. Data link provided situational awareness, but not control. They were fundamentally different philosophies. 1983 – Revelation to the West. Western intelligence had fragmented knowledge of the MiG-29 through satellite imagery and defector reports. But the first visual confirmation came in September 1983 when 3 MiG-29s of the 234th Frontal Fighter Regiment were photographed by KH-11 satellite during exercises in Kubinka. The CIA analysis was alarming. New Soviet fighter demonstrates capabilities comparable or superior to the F-15 in close-range combat. The LURS allows extreme maneuverability. Radar appears to have look-down, shoot-down capability. R-73 missiles with helmet-mounted sight pose a significant threat in a dogfight.
1988 – The Finnish Shock. The first real contact between the MiG-29 and Western pilots came in July 1988 during a diplomatic visit to Helsinki. The Soviet Union, in a gesture of détente, sent 2 MiG-29s for an air demonstration. Finnish Air Force pilots were granted permission for evaluation flights. Major Matti Huskonen, a veteran Finnish pilot with 3,000 hours in the F-18 Hornet, took a 30-minute flight. His report? Maneuverability is spectacular. At low speeds, below 400 knots, the MiG-29 surpasses any Western fighter I have ever flown. The helmet-mounted sight system allows off-foresight engagement. I can aim the missile just by looking at the target without needing to point the aircraft's nose. This is revolutionary in a dogfight. But he continued, ergonomics are terrible. Instruments are confusing. Rear visibility is limited. Radar seems functional, but the interface is primitive. Range is short, and most critically, there is no data link. The MiG operates alone, no shared situational awareness. It was confirmation of what analysts suspected. The MiG-29 was an excellent dogfighter, but deficient in everything else. 1989 – The Wall Falls. The collapse of the Eastern Bloc brought an unexpected consequence. East Germany possessed 24 MiG-29s of the LSK, Luftstreitkräfte. With reunification, these fighters passed to the control of the Luftwaffe. For the first time, NATO had full access to the MiG-29. Testing began at Laga Air Base in 1991. German pilots, many trained in the F-4 Phantom, were assigned to evaluate the real capabilities. Oberst Johannes Steinhoff, commander of the test squadron, said, "It is a formidable aircraft in some areas, inadequate in others. Maneuverability is better than the F-16 at low speed. The R-73 with the HMS is very dangerous in visual combat, but the radar is unreliable, maintenance is a nightmare, and there is a complete lack of data fusion systems." The Luftwaffe conducted dissimilar air combat training exercises, MiG-29 versus F-16 and F-15. Rules: combat initiated within visual range, simulating a dogfight. Results were revealing. In pure 1v1 engagements, the MiG-29 won 58% of the time, but in 2v2 combat or larger, where coordination and communication mattered, the victory rate dropped to 32%. It confirmed the emerging doctrine: numbers do not defeat networks. 1991 – Desert Storm. The Gulf War was the first real test of modern air combat systems against forces equipped with Soviet hardware. Iraq possessed a significant air force, 750 aircraft, including MiG-29s, MiG-25s, MiG-23s, Su-22s, Mirage F-1s. In the first 2 days of Operation Desert Storm, the coalition established absolute air superiority. AWACS coordinating strikes, F-15Cs on cap patrol, suppression of air defenses by F-4G Wild Weasel and AGM-88 Harm destroying SAM radars. Iraq attempted to respond. MiG-29s were sent to intercept attack packages. January 19, 1991, 3:42 p.m. Two Iraqi MiG-29s took off from Al-Taqadum Air Base, attempting to intercept an F-15C formation of the 58th TFS. The Iraqi pilots, trained by Soviet instructors, veterans of the Iran-Iraq War, followed classical doctrine, low-altitude approach to avoid radar detection, rapid climb for engagement. But AWACS saw everything. The E-3 Sentry tracked the takeoff, plotted the trajectory, alerted the F-15s. Captain Rick Tellini, F-15C pilot call sign Citgo 87, received the vectoring. Citgo, Magic, Bandits Bullseye 310, 45 miles, low, heading south. Tellini turned for interception. The APG-63 radar locked on to contacts at 48 kilometers. IFF, identification friend or foe, confirmed hostile. Citgo 87, Tally 2, confirm hostile. Citgo 87, cleared hot. Tellini fired two AIM-S Sparrows, semi-active missiles guided by the F-15's illumination radar. Time of flight, 23 seconds. The Iraqi pilots never knew what hit them. The first MiG exploded in a fireball at 6,000 meters. The second tried to evade, but the second Sparrow found it during a breakout maneuver. Both destroyed. Duration of combat, 41 seconds. In 6 weeks of war, Iraq lost 35 aircraft in air combat, including 5 MiG-29s. All victories were by the coalition. Iraq did not shoot down a single Allied fighter in air-to-air combat. It was a complete humiliation. USAF post-conflict report. The MiG-29 proved to be incapable of operating effectively in a modern combat environment. Lack of AWACS, absence of data link, limited range radar, and inadequate pilot training resulted in a total inability to contest coalition air superiority. But there was another interpretation. General Chuck Horner, commander of the coalition air forces. It wasn't fair. They were fighting the war of the past. We were fighting the war of the future.
Kubinka Air Base, Soviet Union, 1984. VVS Air Combat Training Center. Colonel Anatoly Kwocher adjusts his flight helmet, checks the analog gauges of the MiG-29, and shoves both Klimov RD-33 engine throttles to maximum military power. 18 tons of thrust roar. The aircraft accelerates down the cracked concrete runway, passes 280 kilometers per hour, and Kwocher pulls the stick. The MiG leaps into the sky at a 40-degree angle, afterburners alight, leaving a plume of black smoke. Today is a dissimilar dogfight exercise. Kwocher is in the MiG-29. His opponent, Major Viktor Pugachev, is in a Su-27 flanker. Another fourth-generation fighter, larger, heavier, with superior range but inferior agility. The mission? To prove that Soviet air combat doctrine is still valid. Because there are doubts among young officers, among engineers, among GRU analysts reading Western reports. Some question whether the MiG-29 is truly a match for the F-15, or if it is just propaganda for political consumption. Kwocher does not doubt. He flew against American instructors in simulated exercises dating back to 1975, when U.S.-USSR relations allowed certain controlled military exchanges. He knows Western tactics. He knows their weaknesses. Americans rely too much on technology, he told his students during the morning briefing. They believe radar and missiles solve everything. But when radar fails, when the missile misses, when combat enters a visual dogfight, pilot skills matter, and we are better pilots. It was not empty arrogance. Soviet pilots trained differently. Western training, especially USAF, emphasized procedural discipline, checklists, protocols, following established doctrines. Predictability was a virtue. Coordination was essential. Soviet training emphasized improvisation. Pilots were taught to fly on the edge of the flight envelope, execute maneuvers that manuals classified as unsafe,
respond instinctively without consulting controllers. Kontrolery mogut ashibacja, radar może lgać, только твои глаза и руки могут спасти тебя. Controllers can be wrong, radar can lie, only your eyes and your hands can save you. It was a philosophy forged in real combat. Soviet veterans who fought in Vietnam, Africa, Afghanistan, they knew technology fails. They knew battles are won by pilots who can fly beyond limits, who do not panic when electronic systems die, who rely on instinct more than computers. Quotier reaches 12,000 feet. Pugachev in the Su-27 is 5 kilometers north, climbing for interception. Ground controllers monitor but do not interfere. Exercise rules: combat begins when both pilots have visual contact. No real missiles, only HUD cameras recording simulated launches. Varudi, я вижу тебя. 2. I see you. Quotier turns north, accelerates to 600 knots. The Su-27 is larger radar signature, easier to detect. But it also has more powerful engines. In a pure race, the flanker wins. But Quotier does not want a race. He wants a trap. He dives abruptly, cutting power, throwing the MiG-29 into a 50-degree descent. Speed increases, 650 knots, 700, 750 knots. Altimeter plunging, 10,000 feet, 8,000 feet, 6,000 feet. Pugachev sees the maneuver, recognizes the tactic, baiting. Quotier wants him to chase, wants him to make the classic mistake, diving after the target, gaining excessive speed, losing maneuverability in the recovery. Pugachev does not bite. He maintains altitude, circles above, waiting, patient. Quotier levels out at 3,000 feet, pulls 9 Gs in the recovery. Gravitational force compresses his spine. Blood drains from his brain. Vision narrows into a gray tunnel. He contracts his abdomen and legs, forcing blood back to his head, an anti-G technique Soviet pilots practice until it becomes a reflex. He looks up through the canopy. Pugachev is still there, circling, an eagle waiting for the moment. Ты думаешь, что я забыл старую школу? You think I forgot the old school? Quotier smiles and executes a maneuver no Western pilot would attempt. He cuts both engines.
The MiG-29 decelerates violently from 650 knots to 400 in 6 seconds. It is a more effective air brake than any aerodynamic surface. Pugachev, circling above, suddenly realizes his target is decelerating faster than possible. Overshooting is inevitable. The Su-27 passes ahead of the MiG by sheer inertia. Quotier relights the engines, full power, pulls the stick back. The MiG pitches up, nose pointing vertically upward. He is now behind Pugachev, 6 o'clock, 800 meters, perfect position for a kill shot. Busk! Busk! Launch! Launch! The HUD camera records the simulated lock. The R-73 would have hit. Pugachev curses over the radio. Quotier laughs. The exercise ends. Both land. In the debriefing, the regimental commander, Colonel General Ivan Tretiak, analyzes the recordings. This, he points to the screen showing Quotier's deceleration maneuver, is why the MiG-29 is superior. It is not radar, it is not a missile. It is the pilot, it is the aircraft that allows the pilot to do impossible things. But a young captain in the room, Mikhail Turin, newly arrived from the academy, raises his hand. With respect, Colonel General, but what would happen if there were more targets? What would happen if, while Quotier was executing his maneuver, another American fighter, unseen, were tracking him on radar 50 kilometers away? Silence. Tretiak stares at Turin. For a long moment, no one breathes. Captain, are you suggesting our doctrine is flawed? Turin does not back down. I am suggesting, sir, that our doctrine was developed for a previous era of combat. One-on-one, visual. But Americans do not fight that way. They fight in a network, multiple coordinated fighters, AWACS, data link. They see everything before they enter visual range. It was heresy. Decades of Soviet doctrine prioritized visual combat. That was where pilots mattered. That was where courage and skill won. But Turin was right, and everyone in the room knew it.
The technological abyss. What truly separated East from West? 1987. Angstrom Semiconductor Factory, Zelenograd, USSR. Engineer Dmitry Lavrov examines the silicon wafer under an electron microscope. Laser-etched circuit lines snake across the crystalline surface. Transistors, resistors, capacitors integrated into a single chip. It is a processor intended for the new improved radar system for the MiG-29M. But there is a problem. The lithography process is limited to 5 microns, 5 millionths of a meter. It is the Soviet state-of-the-art. But Western engineers were already producing chips at 1.5 microns and were working on 0.8. The difference seems small, but the impact is exponential. A 5-micron chip can contain 50,000 transistors. A 1.5-micron chip can contain 500,000. More transistors mean more processing power, more memory, more capacity to execute complex algorithms, like fusing data from multiple sensors, tracking multiple targets, filtering electronic jamming. The MiG-29 with the N019 radar processed data at a speed of 1 MIPS, 1 million instructions per second. The F-15C with the APG-63 processed at 5 MIPS. The F-15E with the APG-70 would process at 15 MIPS. It was not just a quantitative difference, it was qualitative. The Soviet radar could detect 10 targets, track 2. The American radar could detect 40 targets, track 8, engage 4 simultaneously. And the gap was widening. Lavrov submits a report to the Ministry of Electronic Industry. We need to invest in a new generation of lithography equipment. We need to buy from the Netherlands, from Japan, or develop domestically. Otherwise, we will be permanently behind the West. The response was predictable. Limited resources. Prioritize production with existing technology. It was a vicious circle. Inferior technology produced inferior systems, which required more units to compensate for quality with quantity, which consumed resources that could have been invested in research. But there was another dimension to the problem. Software. 1988. Keldysh Institute of Applied Mathematics, Moscow. Programmer Alexei Petrov works on a multiple target tracking algorithm for the Su-27's radar. Language: assembler for the Elbrus I processor. Available memory: 256 kilobytes. For context, the 1984 Apple Macintosh had 128 kilobytes of RAM and was considered a basic personal computer. The most advanced Soviet fighter radar had only twice that. Petrov needs to implement a Kalman filter, a mathematical algorithm that predicts the future trajectory of targets based on past observations, essential for calculating missile firing solutions. But the algorithm requires matrix computation, operations that consume memory and processor cycles. He optimizes, cuts resources, limits precision, implements approximations. In the end, it works, but only for 6 simultaneous targets, not 10 as the specification required. Meanwhile, American programmers working on the APG-70 had 2 megabytes of RAM. They could implement more sophisticated filters, track more targets, maintain greater precision. But the gap was not just hardware. It was development culture. The USSR did not have a robust civilian software industry. It did not have thousands of programmers trained in universities working on commercial applications, developing reusable libraries, creating development tools. The US had Silicon Valley. It had Microsoft, Apple, IBM. It had a culture of decentralized innovation where thousands of engineers experimented, failed, learned, iterated. The USSR had government institutes, bureaucracies, 5-year plans.
innovation on demand versus emerging innovation, and the second always wins.
The missile problem. The MiG-29 carried two main types of air-to-air missiles, R-27 AA-10 Alamo, medium-range missile, semi-active radar-guided, maximum range 80 kilometers, but effective range against a maneuvering target 35 to 40 kilometers. It required the MiG's radar to maintain continuous illumination of the target until impact, meaning the fighter could not maneuver aggressively, could not break lock, was vulnerable during the missile's entire flight time. R-73 AA-11 Archer, short-range missile, infrared-guided, range 30 kilometers. It had a unique capability, off-bore sight cueing via the Shell 3UM helmet-mounted sight system. The pilot could aim the missile just by looking at the target, up to 60 degrees off the aircraft's nose axis. In a visual dogfight, the R-73 was lethally effective, better than the AIM-9 Sidewinder of the same era. But modern combat did not happen in a dogfight. The F-15C carried the AAM-12 AMRAAM, a medium-range missile with active radar on board. Fire and forget. The pilot fired, the missile flew autonomously, the internal radar locked the target, and the launching fighter could maneuver immediately, engage another target, or flee. Effective range 70 to 100 kilometers, depending on altitude and flight profile. The USSR attempted to develop an equivalent, the R-77 AA-12 Adder, but the program was delayed by technical problems. First operational test was only in 1991, mass production 1994. Too late. Throughout the 1980s and early 90s, the MiG-29 fought with previous generation missiles against adversaries with superior technology. And missiles are what matter. Dogfighting is the exception. The rule is whoever fires first, from farther away, with the more reliable missile, wins. Maintenance, the logistical nightmare. The MiG-29 was designed for operation in austere conditions, damaged runways, forward bases with minimal infrastructure, maintenance by technicians with basic training. Air intakes had FOD doors that closed during taxiing and takeoff, preventing debris ingestion. Engines could operate with lower quality fuel. The structure was robust. But it came at a cost. Lifespan of the RD-33 engine, 1,000 hours. The F-100 engine of the F-15, 4,000 hours. Interval between major overhauls, the MiG-29 required a complete structural inspection every 2,500 flight hours. The F-15, 8,000 hours. Radar reliability, the NO-19 had an MTBF, mean time between failures, of 50 hours. The APG-63, 250 hours. The MiG-29's hydraulic systems operated at 280 bar of pressure, very high, causing accelerated wear of seals, requiring frequent component replacement. The German Luftwaffe, after reunification, calculated the operational cost per flight hour. MiG-29, $7,200. F-16C, $4,500. F-15C, $6,800. The MiG was more expensive to operate than the F-16, even though it was a smaller, simpler fighter, and it had inferior operational availability, an average rate of 60%, compared to 75% for the F-16. For an Air Force with a limited budget, this meant that each MiG-29 flew less, pilots trained less, and combat readiness was inferior. 1991 to 1999, the decade of revelation. Operation Deny Flight, Bosnia, 1994. 3 years after the collapse of the Soviet Union, the Yugoslav Civil War would test the MiG-29 again. The Air Force of the Republika Srpska operated 6 MiG-29s inherited from the former Jugoslavenska Ratna Aviacija. NATO established a no-fly zone over Bosnia in April 1993. Any military aircraft violating the airspace would be intercepted and, if necessary, destroyed. February 28, 1994, 1:14 p.m. 4 Serbian MiG-29s take off from Banja Luka. Mission: ground attack against Bosnian positions. Pilots know NATO is monitoring. But they bet on speed, quick entry, attack, exit before Allied fighters can respond. But AWACS E-3 saw the takeoff in real time. Captain Robert Wright, piloting in USF F-16C, receives the vectoring. Cowboy 3-1, Magic. Bandits 085, 43 miles, low, heading south, weapons free. Wright accelerates for interception. His wingman, Captain Scott O'Grady, maintains formation. They are at 25,000 feet. The MiGs are at 5,000, flying on the deck, trying to use mountains to mask their radar signature. But the F-16's APG-68 radar operates in look-down, shoot-down mode. Ground clutter is filtered out. Targets are sharp. Wright locks the first MiG at 38 kilometers. IFF confirms hostile. Cowboy, captured target, engaging. An AIM-120 AMRAAM leaves the rail. Another. Wright fires 2 missiles in a 3-second sequence, then breaks right, gaining energy. The Serbian pilots do not know they're being engaged until their RWR systems explode in alarm, but it is too late. The first AMRAAM detonates near the formation leader. The MiG-29 loses its right wing, enters a flat spin, impacts a mountain 6 seconds later. The second missile pursues the wingman. The pilot ejects. The K-36D seat works perfectly, launching him to 400 meters altitude. He survives, but is captured by Bosnian forces 3 days later. The 2 remaining MiGs immediately abort the mission, returning to base at low altitude, jettisoning ordnance to gain speed. Duration of engagement: 2 minutes and 12 seconds. Wright never saw the MiGs visually. Post-operation analysis. NATO intelligence recovered the wreckage of the shot-down MiG. Analysis revealed the N-19 radar was operational at the moment of impact, but had not detected the F-16s. Insufficient range, inadequate operating mode for the combat scenario. The RWR system worked, alerting the pilot to enemy radar illumination, but only 10 seconds before impact. Insufficient time for an effective reaction. The R-27 missiles loaded on the pylons were never fired. It was a pattern that would repeat. Second kill, February 28, 1994, 1:52 p.m. Less than 40 minutes later, another pair of Serbian MiG-29s attempts a similar mission. This time, they are intercepted by a Dutch F-16 of the KLU, the Koninklijke Luchtmacht. Major Peter Tanking, an experienced pilot with 1,200 hours in the F-16, engages at 32 kilometers. Boxer lead, splash 1 MiG-29. It is the first air-to-air kill by the Dutch Air Force since World War II. The pattern is clear. The MiG-29, operating without AWACS support, without data link, with limited range radar, is vulnerable to Western fighters operating in an integrated network. 1995, post-mortem of Soviet doctrine. Russian military analysts, now without the ideological restrictions of the Soviet regime, begin an honest re-evaluation. Major General Alexander Harshevsky, former commander of VVS Fighter Aviation, publishes an article in Voyenная Мысль, Military Thought, the main Russian military doctrine magazine. The MiG-29 Fulcrum is an excellent aircraft, but it was designed for a war that no longer exists. It was designed for visual combat, for dogfights over European battlefields, for an environment where ground controllers would coordinate interceptions. But modern warfare is not like that. It is network warfare. It is information warfare. It is a war where sensor fusion, data link, and shared situational awareness determine the winners. Our pilots are brave and skillful. Our aircraft are capable. But we are fighting with an obsolete philosophy. We need to accept that we made a strategic mistake. We need to learn from adversaries. We need to develop new doctrine before it is too late. It was a remarkable admission, but it was also an epitaph.
because post-Soviet Russia did not have the resources to implement the necessary changes. The economy was collapsing. The military budget was cut by 80%. Factories were closing. Engineers were emigrating to the West. The MiG-29 would remain in service, not because it was adequate, but because there was no alternative.
Kosovo, 1999. The final test. March 24, 1999. Operation Allied Force begins. NATO begins a bombing campaign against Yugoslavia in response to ethnic cleansing in Kosovo. It is the largest Allied military operation since the Gulf War. 1,000 combat aircraft, 200 targets per day. Objective: force Slobodan Milosevic to withdraw Serbian forces from Kosovo. The Yugoslav Air Force, Ratno Vazduhoplovstvo I Protivvazdušna odbrana, has 14 operational MiG-29s against 1,000 NATO aircraft. The odds are impossible. But Serbian pilots decide to fight anyway. Colonel Milinko Pavlović, the same pilot from the prologue of this narrative, commands a squadron of 6 MiGs based at Batajnica Air Base, near Belgrade. He knows survival is unlikely, but there is a question of honor. They think they can bomb our country with impunity, he tells his pilots during a briefing on the night of March 23rd. We will show them that Serbs do not surrender without a fight. The Serbian strategy is simple. Preserve strength. Do not engage unless there is a clear opportunity. Use hit-and-run tactics. Survive. But strategy collides with reality. First day of combat, March 24th, 7:47 p.m. 2 MiG-29s take off to intercept a NATO attack package approaching Belgrade. Pilots, Major Iljo Arizanov and Captain Nedeljko Tosic. AWACS detects the takeoff instantly. 4 F-15Cs on CAP patrol are vectored for interception. Arizanov sees the F-15s on his radar at 42 kilometers, the absolute limit of N019 detection in ideal conditions, but the Eagles had already been tracking him for 3 minutes. He tries the classic tactic, dive to low altitude, attempting to use mountains to break the enemy radar lock. But the AIM-120D does not care about mountains. Captain Jeff Huang, yes, the same one, fires at 68 kilometers. The missile flies a ballistic trajectory over the terrain, then dives in the terminal phase, active radar locked. Arizanov ejects 8 seconds before impact. Tosic sees the explosion, panics, also ejects. Both survive. Second day of combat, March 25th, 2:23 p.m. 3 MiGs attempt a surprise attack against an F-117 Nighthawk returning from a bombing mission. The idea is that the F-117, a stealth aircraft without air-to-air capability, would be easy prey. But the F-117 does not fly alone. 4 F-16Cs escort at a distance, and AWACS sees everything. Before the MiGs get within 20 kilometers of the Nighthawk, they are intercepted by F-16s firing AMRAAMs. 1 MiG shot down, pilot killed. 2 remaining flee.
March 26th, Pavlović's day. Colonel Pavlović decides to take a risk. Serbian intelligence identified a pattern in NATO controls, a 12-minute coverage gap between cap shifts over the northern sector of Kosovo. Small window, but a window. He will take off with a wingman during the gap, approach low and fast, attempt a single-pass engagement against any target of opportunity, then flee before reinforcements arrive. It is a desperate plan, but all options are desperate. March 13, corrected date for narrative continuity, 2:37 p.m. 2 MiGs roll onto the Batajnica runway, Pavlović and Radosavljević. Engines roar, afterburners light up. Takeoff. They fly at 200 feet altitude, weaving among valleys, using terrain for cover. Radar off. Electronic emissions would give away their position. Only eyes and instinct. But AWACS does not need emissions to detect. It has look-down radar powerful enough to see even low-altitude aircraft against ground clutter. and the E-3 Sentry orbiting 100,000 feet over Macedonia sees them. Captain Jeff Huang receives the order. Dirk 5-2, Bandits Bullseye 095, 70 clicks low, cleared hot. Pavlovich does not know he has been detected. His radar is still off. He flies on the assumption that he is invisible. It is the last mistake he will make. Huang engages as described in the prologue. 2 AMRAAMs, 2 MiGs destroyed. Pavlovich dies without seeing the enemy. Radosavljevic ejects but is severely wounded. News reaches the Serbian command within minutes. Air Force Commander Major General Spasoje Smiljanic makes a decision. It's over. We cannot continue losing pilots and aircraft in impossible engagements. All remaining MiG-29s are grounded. We will hide them in fortified hangars. We will preserve what is left. 8 days of war, 5 MiG-29s shot down, 4 pilots killed, 3 captured. 0 kills against NATO. It is the end of the MiG-29 era as a credible threat. Lessons learned in blood. Why technology alone is not enough. Ramstein Air Base, Germany, April 99, post-operation conference. A room full of NATO officials, Americans, British, French, Germans, Dutch. General John Jumper, commander of Allied Air Forces, is at the podium. Screens show statistics. NATO aircraft lost in air-to-air combat, 0. Serbian aircraft shot down, 13, including 6 MiG-29s. Combat missions flown, 38,000. Success rate in aerial interdiction, 94%. Jumper speaks in a calm, measured voice. Kosovo proved that transformation in military affairs is real. Network-centric warfare works. Sensor fusion works. AWACS integrated with 4th-generation fighters equipped with AMRAAMs creates a kill zone where adversaries cannot operate. We must not succumb to arrogance. The MiG-29 is not a bad aircraft. The Serbian pilots were not incompetent. They were brave. They tried. They failed because they were forced to fight an asymmetrical war with inadequate resources. If these same MiGs had their own AWACS, data link, radar modernization, active missiles, would it be a different story? Perhaps. They would not win, but they would not be shot down so easily. A Luftwaffe officer raises his hand, Oberst Klaus Redberg, who flew the MiG-29 of the former East Germany. General, may I add a perspective? I flew the Fulcrum for 3 years. It is a magnificent aircraft in many ways. Maneuverability is exceptional. The R-73 with the helmet is lethally effective at close range, but he chooses his words carefully. The radar is limited. Ergonomics are poor. Range is short. But the biggest problem is not technological. It is operational. The MiG-29 was designed for a different philosophy of employment. The Soviets believed in centralized control. The West believes in decentralized autonomy. When ground controllers are eliminated, as they were in Kosovo, MiG pilots are isolated, alone, blind. But there is another voice in the room. CIA intelligence analyst Sarah Mendelson, a specialist in Russian military doctrine. She projects a map onto the screen, shows Russian territory. Russia still operates 400 MiG-29s. Many obsolete, yes, but they are also developing the MiG-29 SMT with modernized avionics, Zhuk-ME radar, capability for the active R-77, and, most importantly, they have massive air defense infrastructure. S-300, S-400, redundant command and control systems, AWACS A-50, long-range Su-27 and Su-35 fighters. It is not an isolated force. It is an integrated system. Underestimating them because we easily defeated the Serbs would be a strategic mistake. Jumper nods. That is precisely why we conduct this debriefing. Victory teaches less than defeat. We need to understand not only what we did right, but what future adversaries could do differently.
May 1999, Moscow, Russian Ministry of Defense. Russian generals watch the same presentations. They draw different conclusions. Colonel General Anatoly Kornukov, VVS commander, does not hide his frustration. The Serbs fought bravely, but with tactical stupidity. They sent MiG-29s without support against the entire NATO armada. Of course, they would be massacred. But the lesson is not that the MiG-29 is obsolete. The lesson is that obsolete doctrine leads to defeat. We need to modernize not only equipment, but thinking. He points to a Russian intelligence report on NATO operations. They fly in integrated packages, never an isolated fighter, always AWACS, always wingmen, always SEAD support, always aerial refueling available. They build a network. We have the technological capability to do the same. The A-50 exists. The Wimpel data link exists. It just isn't integrated into all aircraft. The R-77 exists. It just hasn't been mass-produced due to lack of funds. The problem is not engineering. It is political priority. But the political reality of Russia in 1999 does not allow for large investments. The defense budget is a fraction of what it was in the Soviet era. Only critical projects receive funding: strategic nuclear forces, submarines, Moscow defense systems. Tactical aviation, low priority. The MiG-29 will continue flying, but without significant modernization.